Hello everyone. Welcome back to my channel. In this video, I'll show you how to use Virtual Machine Manager to create a guest virtual machine. I will walk you through every option in Virtual Machine Manager so you can properly configure the virtual hardware to install Rocky Linux or any other operating system. So, to ensure you don't miss anything, make sure to watch the video all the way through. Also, ensure that the KVM hypervisor is properly installed on your Linux distribution and that your host is virtualization ready. If you haven't already done so, please watch my other video on how to install the KVM hypervisor on your Linux distribution. I will include the link in the description. Before you start creating a guest virtual machine, you must also enable XML Editing because you will be adding some to modify certain aspects of the virtual hardware of the guest virtual machine. So, in the Virtual Machine Manager, go to Edit, then Preferences, and enable XML Editing. To begin creating a Rocky Linux guest virtual machine, click the computer icon in the Virtual Machine Manager's upper left corner. This will launch a wizard that will walk you through the process of creating a new virtual machine in 5 easy steps. The step 1 of the wizard is to choose how you want to install the operating system. And step 2 of the wizard is to provide the installation source for whatever option you chose in step 1 of the wizard. Choose this option if you are installing the operating system from an ISO image downloaded from the official website of a Linux distributor. When choosing an ISO image, ensure that it is actually an OS installer. In this case, it's a Rocky Linux 9 installer. Also, make sure that the checksum of the ISO image matches the one provided by the OS distributor to ensure that it has not been tampered with. As you can see, the SHA-256-bit checksum computed on the installer ISO image matches to the checksum provided by the Rocky Linux OS distributor. Select the second option if you prefer to install an operating system over the network. For this, you must provide the URL of the installation tree. For example, if you want to install Rocky Linux version 9.3 over the network, then go to its installation tree. Copy the URL and paste it here. As you can see, the URL has been validated as a proper OS installer tree. Choose the third option if you've already downloaded the ready-to-use QEMU image that most operating system distributors provide. For example, if you want to download the QEMU virtual disk image with Rocky Linux version 9.3 already installed, navigate to the images directory. Select your architecture, in this case x86-64. Search for QEMU and download any image that is relevant to you. Once the download is finished, copy the QEMU image to the KVM Virtualization's default images directory. If you use any Red Hat-based Linux distribution, you must also set up the appropriate SE Linux file contexts. Then, run this command to set the root password. And remove the Cloud Init program so that you can use it locally. You can now use this image to create a ready-to-use virtual machine. Alternatively, if you have a QEMU or raw virtual disk image with an operating system that you have installed previously, you can also use that. Finally, if you want to install the virtual machine manually, choose the fourth option. I will, however, install the Rocky Linux version 9.3 operating system using the ISO image that I downloaded from the Rocky Linux website. Click the forward button for the next step. In step 3 of the wizard, you must set the amount of host memory and the number of virtual CPUs that the guest virtual machine will have. As you can see, I have 16 GB of memory and only 4 CPUs because I am using an old Intel i5 Generation 4 processor. If you're using a new processor, you'll have something like 16 CPUs. I'll set the memory to 4 GB and the CPU to 1. You can, however, set them to meet your needs. Also, keep in mind that the amount of memory and CPU count you specify here are both fixed. You might also want to enable the feature that allows you to hot plug additional memory or CPUs while the guest virtual machine is running. I will show you how to enable that feature while explaining advanced settings. For now, click the forward button for the next step. Step 4 of the wizard is about allocating storage space for the guest virtual machine. Uncheck this option if you do not want to allocate a storage device for the guest virtual machine. This will be useful, for example, if you want to create a virtual machine with a specific type of virtual hardware pre-configured for testing Linux distributions that come with live ISOs such as Fedora and Ubuntu. Use this option if you want the Virtual Machine Manager to create a storage device for you. The virtual storage disk created will be of type QEMU and it will be saved in the default directory-based storage pool of the KVM hypervisor, which is var lib Virt-Managers. If you want to create storage on other types of storage pools, choose this option instead. If you have already created other types of storage pools and want to add storage to one of them, you can do so here. If you don't know what a storage pool is or want to create one, check out my other video. In that video, I go over how to create and manage a directory-based storage pool. I will include the link in the description. Because I haven't created any other storage pools on this computer, I'll use the default storage pool as an example to create virtual storage disks. Here, you can create both raw and QEMU storage disks, as well as specify the storage capacity. Instead of using virtual disks, you can also use this setup to install Rocky Linux on a physical partition or even an LVM logical volume. Please keep in mind that you can only take internal snapshots of your virtual machine if you use QEMU storage type for it. You cannot take internal snapshots if you install the operating system on a virtual machine that uses other types of storage, such as raw, physical partition, and LVM logical volume. If you prefer, you can also use the command line interface to create a virtual storage disk. In this example, I'll use the command line tool QEMU img to create a virtual disk of type QEMU in the KVM Virtualization's default storage pool. The QEMU virtual disk created with this command will be identical to the one created using the Virtual Machine Manager in the wizard. The virtual disk can now be used in your guest virtual machine. I will, however, allow the virtual machine manager to create a storage device for me. I'll set the storage size to 40 GB, but you can set whatever size you want. Then click the forward button to proceed to the fifth and final step of the wizard. Enter the name of the guest virtual machine. I'll give it the name Rocky 9 Silver GUI. Now, check the Customize Configuration Before Install option to continue configuring the advanced options. Finally, click the Finish button to complete the wizard. Here, you can further customize the settings and fine-tune your guest virtual machine. I will just go over some of the most important features here. Review these features and, if necessary, implement them, otherwise, discard them. The Overview section allows you to configure the basic information about the guest virtual machine. The UUID shows the universally unique identifier of the virtual machine. In addition to the name, which should be unique from any other guests on the hypervisor, you can also provide a title and description to enhance the identification of guest virtual machines in the Virtual Machine Manager. KVM supports two types of chipsets, i440FX and Q35. The older i440FX only supports PCI, whereas the new Q35 natively supports PCIe, allowing GPU pass-through. So, make sure you have the Q35 chipset selected. This is also the default. Next, choose the firmware. The BIOS firmware will be the default choice. This firmware is fully supported by the KVM hypervisor. By using this firmware, you can take internal snapshots, both offline and online, which is extremely useful when experimenting with something. Use this firmware if you want the virtual machine to boot with modern UEFI firmware and secure boot enabled. At the time of recording this video, internal snapshots could only be taken when the virtual machine was offline and not online. The UEFI firmware and this firmware are nearly identical, with the exception that, when using this firmware, you cannot take internal snapshots both offline and online. To know what all these firmwares can do, then open the terminal and go to the path User, Share, QEMU, Firmware, where you can find the details of these firmwares. For example, if you want to learn about the features of the UEFI firmware, you can look at its JSON file. As you can see, using this firmware gives your guest virtual machine secure boot with system management mode, with secure boot enabled, and Microsoft certificates pre-enrolled. I will set the UEFI firmware for this guest virtual machine and click the Apply button to confirm. Next, go to the CPU section. In step 3 of the wizard, you assign the guest virtual machine one fixed virtual CPU. If you want, you can also enable the virtual CPU hot plugging feature. This allows you to dynamically change the number of virtual CPUs while the guest virtual machine is running. To enable virtual CPU hot plugging feature, first, set the virtual CPU's allocation slot to have the maximum number of virtual CPUs that you would like to hot plug to the running guest. I will limit the number of virtual CPUs to 3. I only have 4 CPUs because I am using an old 4th generation Intel i5 processor. If you use a new processor, you will have more CPUs. Click the Apply button. Next, in the XML tab, set the current number of virtual CPUs back to 1. So, from now on, whenever you boot the guest virtual machine, it will start with just one virtual CPU, with an additional 2 virtual CPUs available for hot plugging if needed later. In CPU configuration, the CPU is set to host pass-through by default. When the mode is set to host pass-through, the model and the features of the host CPU are exactly passed on to the guest virtual machine. This is also the recommended and the default option. The disadvantage is that the live migration from one host to another with different hardware will be impossible. You can also set the mode to host model. In this mode, a CPU model similar to the host CPU is first chosen from the CPU models list. Then, to get as close as possible to the host CPU, additional features are added. This will not exactly match the host CPU, like the host pass-through, but it will provide many of the benefits of host pass-through, while also making live migration safe. To find out which CPU model and features will be assigned to the guest virtual machine, if the mode is set to host model, then run this command on your host. The CPU model chosen for my computer is Haswell, which is a code name for a processor microarchitecture developed by Intel for the 4th generation core. And these are the features that will be added to make the virtual CPU as close as possible to my actual CPU, which is Intel Core i5-4590. I will, however, set the CPU configuration to host pass-through, as I do not intend to perform any live migration. Use this option to apply a particular CPU topology to your guest virtual machine's virtual CPUs. If you want to simulate any number of sockets, Red Hat recommends using only a single core and a single thread and not overcommitting virtual CPUs for the best performance results. Then, go to the memory section. You can enable the memory hot plugging feature here, in the same way that you enabled it for the CPU. If you don't want hot plugging, just keep the current memory and maximum memory the same. I will, however, enable the memory hot plugging feature. I will keep the current memory allocation of 4 GB bytes while increasing the maximum allocation to 8 GB bytes. With this setup, the guest virtual machine will boot with only 4 GB bytes of memory, with an additional 4 GB bytes of memory available for hot plugging if needed later. Once the Rocky Linux operating system is installed, I'll show you how to dynamically increase or decrease the virtual CPUs or memory of a running guest virtual machine. If you want to share files between the host and the guest virtual machine, enable shared memory. There are some additional steps you must take before you can begin sharing files with the guest virtual machine. I've also uploaded a video that shows how to do it, so take a look at my channel. It's quite old, but if you want the most up-to-date information, see the article I wrote on the same subject. I'll include both links in the description. Check this box if you want this guest virtual machine to boot automatically whenever the host machine boots. Check this box if you want to enable the boot menu every time the guest virtual machine starts. The menu will be displayed for a second or two, and if you press the escape button during that time, you will be given some boot options, including the iPXE. Enable the devices used for booting guest virtual machine in the boot device order. You can rearrange them by using the up and down arrows on the right side of the list. If you want to boot to a different kernel than the one on the boot device, enable direct kernel boot. You can specify the paths to the alternative kernel and initial RAM disk files that are stored on the host system. This option allows you to specify what type of disk bus the guest virtual machine should emulate for its disk device. SATA, which stands for Serial Advanced Technology Attachment, is the most widely used interface in desktops and laptops for connecting storage devices such as hard disk drives, optical drives, and solid-state drives. SCSI, which stands for Small Computer System Interface, is commonly used in servers and workstations that require high throughput and reliability. It is typically used to connect to and communicate with devices such as hard disks, optical drives, scanners, and printers. USB, which stands for Universal Serial Bus, is a standard plug-and-play connection for a wide range of devices. In general, USB is used to connect various types of external devices to computers. And finally, the Virt-I/O disk bus. While you can certainly use the other three disk buses, they will be somewhat slow compared to Virt-I/O because the hypervisor must emulate the actual physical device. This emulation is both inefficient and time-consuming. Virt-I/O disk bus, on the other hand, has been purpose-built and optimized for virtualization. As a result, there will be no processing overhead, and performance will be naturally excellent. This is also the recommended option. Choose this option if you want to disable writing on the virtual disk and make it read-only. In this case, this makes no sense because we are installing Rocky Linux and need to write to the disk. This option is typically used when you want to share data on the disk with read-only access. Check the shareable box if you want a single virtual disk to be shared by multiple cluster-aware guests. Shared disks should not be used in every situation. Shared disks are only appropriate for applications such as clustered database servers and other highly available services. Attaching a shared disk to multiple guests, which are not cluster-aware, increases the likelihood of data corruption because their disk reads and writes are not coordinated. Next is the serial number. If you have a software licensed to the hard disk serial number and you want to run it on a guest virtual machine, you can enter it here. If you want to know the serial number of your hard disk, then go to your terminal and enter this command. You can then look for the hard disk serial number, copy it, and paste it here. You can now use the software licensed to the hard disk serial number in the guest virtual machine. KVM provides multiple storage caching strategies when configuring a guest virtual machine. You can select any of the caching modes based on your needs. In this mode, the guest's input-output is not cached on the host, but is kept in a write-back disk cache. Use this mode for guests who have a high input-output requirement. This is the best option in general, and is the only option that supports migration. In write-through, the input-output from the guest is cached on the host, but written through to the physical medium. This mode is slower and more prone to scaling issues, and it is recommended for guests who do not support a write-back cache. In write-back, the host page cache is used as read and write cache. Writes are reported to the guest as completed when they are placed in the host cache. The guest's virtual storage adapter is informed of the write-back cache, and therefore, expected to send flush commands as needed to manage data integrity. Please keep in mind that data can be lost in the event of a crash or power outage. Direct sync is similar to write-through, but input-output from the guest bypasses the host page cache. This mode can be useful for guests that do not send flushes when needed. And finally, in the unsafe mode, the host caches, all disk inputs, outputs, and guest sync requests are ignored. Use this mode if you want to prioritize performance gains over the risk of data loss in the event of a host failure. I will set the disk cache mode to none though, as it balances performance and safety. There are two options here: ignore and unmap. When you delete files in the guest virtual machine, the changes are reflected in the guest file system immediately. The QEMU disk image associated with the virtual machine, on the other hand, does not shrink to reflect the newly freed space. You can reclaim that free space by selecting the Unmap option. If you do not want to use this feature, select the Ignore option. I'm going to set it to the Unmap option though. In this section, you can configure Network Device Interface. By default, all virtual machines on the host are connected to the same NAT-type virtual network, named default. Please keep in mind that virtual machines on this default network will have only outbound network access. That is, virtual machines will have full network access, but devices outside the host will be unable to communicate with virtual machines within the host. Only the host computer will have full access to the virtual machines. The virtual machine, for example, can browse the web, but cannot host a web server that is accessible to the outside world. Only the host computer and, of course, other virtual machines connected to the same default network can access the web server. From a security standpoint, this network is the best option because only you have access to the virtual machine. If you want virtual machines to be directly visible on the same physical network as the host, and also visible to external devices, you must use a network bridge. Choose this bridge device option and provide the name of the network bridge connection. Before opting for this option, however, make sure you have already established a network bridge connection on your host. You will then have a network that can be accessed by other physical machines on the same network as yours, as well as the outside world. The virtual machines that use this bridge device will get an IP address from the same pool as your host computer. If you have not yet created a network bridge and are interested in doing so on your host computer, please see my other video on how to properly install KVM on Linux. In that video, I have explained not only how to create a network bridge on your host computer, but also how to connect it to a virtual network on the KVM, so you can access it by name, such as this one, which I named NW Bridge. If you don't want to go through the hassle of manually creating a network bridge, but still want the guest virtual machine to be accessible from the outside world, including other devices on the same network as yours, you can use the Mac vTap device option. Simply select the Mac vTap device option and point it to the network interface device name of your host computer, which in my case is ENP2S0. Yours will be different. The virtual machine will then get an IP address from the same pool as your host computer. Please keep in mind that your host computer should not have any bridge network set up for this to work. Your guest virtual machine will then be accessible to the outside world, with one exception: your host computer cannot access the guest virtual machine. For instance, suppose you hosted a web server on your guest virtual machine and configured the network to use Mac vTap. Then, the outside world can access the web page you hosted on your virtual guest machine. The web page can also be accessed by other devices on the same physical network as yours, such as your mobile phone. The only computer that does not have access to the guest virtual machine is your own host computer. That is the difference between the Mac vTap network and the network bridge. If you're okay with that, select the Mac vTap option. For this demonstration, however, I will use the default NAT network. When it comes to device models, you have two choices, E1000E and Virt-IO. E1000E is an emulated version of the Linux-based driver for Intel 825 series Gigabit Ethernet network connections. The Virt-IO, on the other hand, is a para-virtualized driver designed specifically for virtualization. In comparison to the E1000E, the Virt-IO has no overhead and it passes network traffic between the virtual machine and the host in the most straightforward way possible. As Virt-IO is the recommended option, I set the device model to Virt-IO. The MAC address is a unique 12 hexadecimal digit string that is linked to a network card in a machine. It serves as a convenient way to distinguish between two different computers. The first 6 hexadecimal digits are reserved for the QEMU emulator. You can change the last 6 hexadecimal digits if you want, but it's best if the emulator sets them for you. If you want to know the IP address of your guest virtual machine while it's running, you can press the refresh button to display it. Uncheck this option if you want to disconnect the network interface card while the guest virtual machine is running. Removing the USB tablet device can help reduce idle CPU usage and context switches. As a result, the guest virtual machine's performance will improve. So, I'll remove the tablet. Next is display. SPI server is used by the KVM hypervisor to display virtual machines using the SPICE protocol. SPI server allows you to access a virtualized desktop or server from the local system or any system with network access to the server. Here, you can set the listen type to address or none. If you choose the listen type to address, you can also specify an optional port number. You can also password protect the display if you want. Let me show you how password protection works on the display server on the other guest virtual machine. Here, I will enter a simple password just to demonstrate. And, as you can see, when I try to run the virtual machine, it prompts me for a password before proceeding. Even if I close this window and try to open the virtual machine in another graphical console, like Virt Viewer, I still need to enter the password. In the sound section, you can add a virtual sound card. You can choose which real-world sound device to emulate using the model option. Depending on your host hardware, there may be additional values as well. Some of the options could be SB16, ES1370, PCSPK, AC97, ICH6, ICH9, and USB. For me, the high-definition audio ICH9 has been automatically selected by the hypervisor. So, I'll go with the default. If you want, you can also configure some advanced options. Simply visit this page. Scroll down to the sound section. And, as you can see, there are many tweaks you can apply. Just open the XML tab in Sound section and add the tweaks you want. Next is QEMU Guest Agent Channel. Make sure you have added this channel with the target name as this one. The QEMU guest agent channel establishes a private communication channel between the host physical machine and the guest virtual machine, allowing you to issue commands to the guest virtual machine's operating system. The guest operating system then responds asynchronously to those commands. For example, after creating the Rocky Linux 9 guest virtual machine, you can use these commands, among many others, from the host to communicate with the guest virtual machine. The QEMU agent support also allows for better integration with the guest. For example, it supports copy and paste between the guest and host operating systems, as well as dynamic resolution changes when the client window is resized or full screened. Once the guest virtual machine is created, you must also install daemon packages in the operating system of the guest virtual machine for this to work properly. For Linux, the packages are QEMU Guest Agent and Spice VD Agent. If the QEMU Guest Agent channel is not already present, you can add it by clicking the Add Hardware button, select Channel, set the device type to Unix socket, and finally select this option. Then, to apply, click Finish. The QEMU Guest Agent channel communicates with the host via this dedicated Spice VMC chart device. It will be added automatically. You don't have to do anything. The video section allows you to configure various video settings. QEMU provides several emulated display devices that you can choose from. Out of all the models, the important ones are QXL, which is set as the default for Windows virtual machines, and Virt-IO, which is set as the default for Linux virtual machines. If you want 3D acceleration, enable it here. If you want the guest virtual machine screen to have a specific resolution after boot, you can specify it in the XML tab of the video section. This is especially useful when you want to install an operating system that doesn't have a graphical interface. With such interfaces, the display will generally have a standard resolution of 1024 by 768 and sometimes even less. So here, for this virtual machine, I will set the display to widescreen resolution 1360 by 768. If you want to use the same widescreen resolution during pre-boot, or while installing the operating system, you should also set the same resolution in the UEFI firmware. I'll show you how to do it in a minute. The next important option you can consider adding is TPM, that is, Trusted Platform Module. TPM technology is designed to provide hardware-based, security-related functions. I'm going to enable the TPM emulator version 2.0. You have now finished configuring the virtual machine with some advanced options. To start the installation of the operating system, click the Begin Installation button. Press the Escape button repeatedly to enter the UEFI firmware interface. Now, go to Device Manager. Then to OVMF Platform Configuration. And then select your preferred resolution. I will set the resolution to 1360 by 768. Then select Commit Changes and Exit option and press Enter to permanently set the resolution. Now, press Escape, and then the Reset option to reboot. You will receive an error message stating, No bootable option found. This is because the ISO file you mounted previously has been unmounted. So, force off the virtual machine. Then, click Show Hardware button. Go to CD-ROM. Then, remount the installer ISO. Now, start the virtual machine again. Click on the View menu and select the option Resize to VM. As you can see, the screen is now resized to 1360 by 768 widescreen. Start the Anaconda installer to begin the installation of Rocky Linux 9.3. We now have a wizard for installing the Rocky Linux. Complete the installation by following the standard installation procedure of the guest operating system. I'll continue the tutorial once I have installed Rocky Linux 9.3. Alright, I have just completed the installation of Rocky Linux. Before we continue, let me quickly adjust the font size. I'm going to install the packages QEMU Guest Agent and Spice VD Agent. These packages are required for better integration with the host, as well as for copy and paste support between the guest and host operating system, and also for dynamic resolution changes when the guest virtual machine window is resized or full screened. As you can see, the packages have already been pre-installed, so there is no issue here. As you may recall, I enabled the hot plugging feature for memory and CPU at the start of this video, which allows you to hot plug additional memory or CPUs while the guest virtual machine is running. Hot plugging allows you to improve the performance of a virtual machine by allocating more resources to it only when critical applications are running and you cannot afford to shut down the virtual machine and experience downtime. Let me demonstrate how to use this feature. Go to the host machine terminal and make sure the guest virtual machine is running. Now, check how many CPUs the Rocky 9 server GUI virtual machine has. As you can see, there is only one CPU. The configuration reflects this as well. Also, the maximum number of CPUs that can be hot plugged is 3. Exactly as I had it set up. You can also check the number of CPUs within the virtual machine itself. Now, while the guest virtual machine is running, I will increase the CPUs to 2. The command is virsh set vCPUs Rocky 9 server GUI 2 and --live. Check the CPU count of the running virtual machine once more. As you can see, the CPU count has been increased to 2. You can also verify the CPU change in the guest virtual machine. Please keep in mind that when you restart the virtual machine, the CPU count is reset back to 1. If you want the CPU to be permanently configured to 2 upon boot, run this command on the host. Change live to config. From now on, when you boot the virtual machine, it will start with 2 CPUs. In a similar manner, you can also add or remove the memory of the running guest virtual machine. First, determine the maximum memory and the memory currently in use in a virtual machine. This will serve as a baseline for your changes as well as verification. As you can see, the memory currently in use is 4 GB, while the maximum memory is set to 8 GB. You can also check the memory in the virtual machine. To dynamically increase the memory of a running virtual machine, for example, to 6 GB, use this command. Check the memory once more. As you can see, the current memory is now set to 6 GB. In the guest virtual machine also, it now shows the memory as 6 GB. If you want the memory to be configured to 6 GB upon boot permanently, you can use this command on the host. Just change current to config. Okay. This brings us to the end of the video on how to use Virt-Manager. I hope you found this video to be informative. In the next video, I will show you how to create guest virtual machines in KVM using only the command line interface. So, stay tuned. Until then, goodbye.